in this section is also something called percent yield. Okay, percent yield is going to be a percentage of how much we actually made. Okay, there's 3 definitions here: theoretical yield, actual yield, and percent yield. Starting with theoretical yield. Theoretical yield is the maximum amount of product that can be produced. So theoretical yield comes from calculation. Okay, so when we do stoichiometry problems, when we do the problems that we have been doing, that is, we're getting the theoretical yield. That is, that in a perfect world where all the reactants get turned into products, that's how much product we should be making, okay? But we rarely ever get this amount because in real life, things happen. Maybe my glassware is dirty and not all my reactants get turned into products because there's side reactions. Maybe I thought that I put this amount, but when I was measuring the water, I didn't measure correctly, and not all the water got into my reaction. So theoretical yield, we get it from math, okay, by doing stoichiometry problems. Actual yield, this is a measured amount of product obtained from the reaction. So actual yield is a yield that you actually get when you actually do the experiment, okay? In this case, since we're doing problems, this actual yield will always be given to you. But in the real world, this is the number, actual yield, you will get it after you do the experiment, okay? So theoretical yield, you get it using math. Actual yield, you get it from actually doing the experiment, okay? For example, let's say you buy, I love eating, I love cookies. If you buy a cupcake or a cookie dough, right? And so in the box, it tells you your theoretical yield is 24 cookies. They're not the ones that are pre-cut. So your theoretical yield is 24 cookies. But in your actual yield, you make less. You make 20, you make 23, or maybe you make more. Oh, you're going to make less, not more. Actual yield is always going to be less than your theoretical yield, okay? Because maybe you didn't scrape the bowl good enough, or you made one cookie a little bit larger than the other one, okay? So actual yield, you get it from actually doing the experiment. Theoretical yield, you get it using math. Percent yield is going to be a percentage of your theoretical and your actual. Percent yield is a ratio of actual yield to the theoretical yield multiplied by 100. So percent yield is at actual yield, so what you got, divided by what you should have gotten, times 100. Remember that for percentage is part over whole times 100. So it's what you actually got divided by what you should have gotten according to your math times 100. Okay, so here we have an example. Now these examples, each different question for percent yield can be written 1,000 different ways, okay? But this is just one example. So it says when 36.8 grams of C6H6 reacts with excess chlorine, the actual yield of C6H5Cl is 38.8 grams. What is the percent yield of C6H5Cl? Okay, so this question is giving us 36.8 grams of C6H6. It's telling us that this reactant is in excess. Now, why is that important? Excess. That is important because our theoretical yield, so the maximum amount of product that we can make, comes from how much product can our limiting reactant made, okay? So if chlorine is in excess, that means that C6H6 is a limiting reactant. So your theoretical yield comes from how much product can the limiting reactant made or makes, okay? What is the percent yield of C6H5 chlorine? Question mark, percent yield. Okay, so this question is also telling us that this is the actual yield. So actual yield for C6H5 is 38.8 grams. Okay, so we have the actual yield. we need the theoretical yield, okay? Because remember that percent yield, the formula for percent yield is at actual over theoretical times 100. Okay, so it's actual over theoretical times 100. We have actual. Now we need to figure out where the theoretical is. To figure out the theoretical, we need to look at how much product can the limiting reactant make. So we're gonna look at the limiting reactant, which is C6H6, and we have 36.8 grams of C6H6. Now, you see how the actual yield is in grams? We need to go now from grams of C6H6 to grams of the product. Okay, so we need to go from grams to grams. That means that's going to be the longest one, that we have to use molar mass twice. So the first step is we need to find the molar mass of C6H6, so then we could go from grams to moles. So carbon, I have 6. Hydrogen, I have 6. I'm going to multiply them times their mass. And the mass of carbon is 12.01 times 6, 72.06. I add them, and I get 78.12 grams per mole. So now I'm going to put this number in the bottom. 78.12 grams of C6H6 for every 1 mole of C6H6. The grams cancel out, so it's basically the same thing that we've been doing this chapter. Now that I'm in moles, now I'm gonna go ahead and use the mole ratio, which is 1 mole for every 1 mole. So it's 1 to 1. So in the bottom, I'm gonna put 1 mole of C6H6 for every 1 mole of C6H5Cl. Like this, the moles of C6H6 are gone. But since the actual yield is in grams, remember that I need to go to grams of C6H5Cl. I need to find the theoretical yield in grams. So now my next step is to use the molar mass. But for C6H5Cl. So I have carbon, hydrogen, and chlorine. 6 carbon times the mass of carbon, which is 12.01, 72.06. I have 5 hydrogen times 1.01, 5.05. Chlorine, I have 1 times the mass of chlorine is 14.01. That is 14.01. When I add everything together, I get 112.56 grams per mole. Okay, now this number I'm going to put it on top. 112.56 grams of C6H5Cl for every 1 mole C6H5Cl. Here the moles cancel out, leaving me in grams. So now I get my calculator. I do 36.8 divided by 78.12 times 112, and I get 53 grams of C6H5Cl. Okay, and that is my theoretical yield. Okay, remember the question was asking me for percent yield. Percent yield is actual over theoretical times 100. The actual was given to me in the problem, 38.8 grams. Theoretical, I just figured out. Okay, so to find percent yield, I'm gonna do actual, which actual yield is 38.8 grams of C6H5Cl over theoretical, which theoretical we just calculated for was 53.0 grams of C6H5Cl times 100. Now, important thing to note is that it has to be the same unit and the same compound, okay? So whatever the question gives you the actual yield for, so in this case they gave us the actual yield for C6H5, that's why we solved for C6H5. That's why we found the theoretical yield for C6H5, because the question had given us the actual yield for C6H5. And since they gave us those in grams, that means that we had to find the theoretical yield also in grams. Okay, so now to find the theoretical yield, I'm going to get my calculator, divide 38.8 divided by 53 grams of C6H5 cancel out times 100, and percent yield equals 73.2%. Okay, and that is my final answer. That means that I only made 73.2%. So only 73.2% of my reactant got turned into products. So your percent yield is always going to be less than 100. It is never going to be greater than 100%, okay? In reality, so in real life, you want to be close to 100 as possible, but in real life, you're never going to really reach 100% for percent yield, okay? You're never really going to make 100%. 100% of all your reactants in real life are not going to be turned into product. So this is good. Okay, so let's do another example that says, if I start with 75 grams of sulfuric acid and produce 7.1 grams of water, what is my percent yield? Okay, so they're asking me for the percent yield of water. Okay, this right here, 7.1 grams of water, that will be my actual yield. So they're giving me that the actual yield for water is 7.1 grams. They're asking me for percent yield. Remember that percent yield is at. So they're really asking me for percent yield. So I'll do it here. Percent yield equals at actual over theoretical times 100. Okay, so they're giving me that the actual yield is 7.1 grams of water. That means that I need to find the theoretical yield. Okay, the theoretical yield, I use it by doing stoichiometry. And in this case, they're telling me that I start with 75 grams of sulfuric acid. So if I start with 75 grams of sulfuric acid, and that decomposes to form water and SO3, how much water am I going to produce? Okay, since they gave me the actual yield for water, that means that I need to find the theoretical yield for water. Excuse me. So I'm going to start, just like in every stoichiometry problem, with what was given to me. 75 grams of H2SO4. Remember that in every stoichiometry problem, I always need to use mole ratio. But in order to use a mole ratio, I need to be in moles. And right now I am in grams. So I need to go from grams of H2SO4 to moles of H2SO4 by using the molar mass of H2SO4. Okay, so to find the molar mass of H2SO4, I have hydrogen, sulfur, and oxygen. I have 2 hydrogens, 1 sulfur, and 4 oxygens. So I'm going to multiply how many of each I have times their mass. So hydrogen, I have 2 of them. Each one has a mass of 1.01. 2 times 1.01 is 2.02. sulfur in the periodic table has a mass of 32.07. So that's 32.07. And each oxygen has a mass of 16 times 4, that is 64. I add all the masses and I get 98.09 grams per mole. Okay, so I'm going to put this number down here. 98.09 grams per 1 mole. So grams of H2SO4 for every 1 mole of H2SO4. Okay, like this, grams of H2SO4 have canceled out. Now I'm left in moles of H2SO4. Now I could use a mole ratio. Okay, so here I had to use a molar mass. Now I'm going to use the mole ratio to go from moles of H2SO4 to moles of water. And my mole ratio is 1 mole of H2SO4 for every 1 mole of water. Okay, since my actual yield is always going to be given to me in grams, because remember that in a lab we can use a scale to get grams. We cannot really use an instrument to get moles. So our actual yield is always going to be in grams. All that means is that we cannot stop here, because right now if we stop, we would be in moles of water. So we need to turn that into grams of water to be in the same unit as our actual yield. So we need to do one more step, in which we go from from moles of water to grams of water. And remember that we do that by you finding the molar mass of H2O. So to find the molar mass of water, we have hydrogen, we have 2 of them, times the mass, that is 2.02. Oxygen, we only have 1, and that's 16. We add them up and it gives us 18.02 grams per mole. Okay, so now we're gonna get the molar mass and we're gonna put that number here in the top. So 18.02 grams of H2O for every 1 mole of H2O. And the reason that we put the grams in the top is, remember, so that moles of water and moles of water cancel each other out. So now what we're gonna do is we're gonna get our calculator and we're gonna get 75. Any number that's in the bottom we're gonna divide, and every number that's in the top we're gonna multiply. So we're gonna get 75 divided by 98.09 times 18.02, and that is going to give us, I'm gonna put it sideways because I barely have any space, 13.77 grams of water. Okay, so this right here, what we found out, that is the theoretical yield. Okay, so this number that we had to do stoichiometry. So we started with the grams, we'd use the molar mass to turn it into moles, and we use a mole ratio to jump from one compound to the next, and then use the molar mass again to go from moles to grams. That number there, that is the theoretical yield. So that is how much we should be making in a perfect world. But remember that the actual yield for this experiment was 7.1 grams. Okay, so to find the percent yield, I'm going to write the formula here once again. We're going to do actual yield divided by theoretical. Okay, so at actual over theoretical times 100. So I'm just gonna plug in my values. My actual yield, according to my problem, was 7.1 grams. My theoretical yield, I figured out it was 13.77 grams of water. This one's also grams of water. Times 100. Okay, notice how the unit and the compound that we're talking about for actual and theoretical are both the same because they cancel each other out. Okay, so now I'm going to get 7.1 divided by 13.77 times 100, and that gives me 51.56% yield for water. Okay, and that's my final answer. That is my percent yield. So that means that I only made 52% of what I should have made. I only made 52% of water. Okay, so this last problem says, what is my actual yield of uranium hexabromide if I start with 83 grams of uranium? So I start with 83 grams of uranium. I have 83 grams. And I get a percent yield of 83%. So my percent yield is 83%. And what the question is asking me for is, what is my actual yield? Okay, so this question is asking me for the actual yield. So what is the yield that I got when I did the experiment? Well, I cannot do the experiment because even if I were to do the experiment, I wouldn't get the same percentage. Okay, what I'm gonna do here is I'm gonna work backwards. So I have the percentage, I have what I started off with, okay, and they're asking me for the actual yield. Remember that percent yield, the formula for percent yield is actual over theoretical, I'm going to write theo, times 100, okay? They're asking me for actual, so they're asking me for actual, question mark. Percent yield, they give it to me. Theoretical, I can figure that out, okay? So I'm going to put a check mark because I can figure out theoretical. Remember, I figure out theoretical by doing stoichiometry problem. So starting with 83 grams of uranium, how much uranium hexabromide can I make? When I do that, so when I do that math problem, I figure out the theoretical. Okay, so I know my percent yield. It was given to me 83%. I know my theoretical yield, not yet, but I will once I do stoichiometry. And then I could just plug in both of these values and solve for my actual yield. Okay, so let's do it. The first thing I'm gonna do is find the theoretical yield by doing stoichiometry. So I start with 83 grams of uranium, and I need to figure out how many grams of uranium hexabromide I can make. Remember, my first step is to go from grams of U to moles of U by using molar mass of U. So uranium is down here. The molar mass is 238.03. So 238.03 grams of uranium for every 1 mole of U. Okay, notice how I put the grams across from each other so that they cancel each other out. Since it is only U and there's no subscript behind it, I just use a number from the periodic table. I don't have to multiply by anything because I only have 1 U. So now that I am in moles of U, now that I'm in moles in uranium, now I could use the mole ratio to jump from one to the other. Okay, so I have 1 mole of uranium for every 1 mole of product. 1 mole of uranium hexabromide 6. Okay, here my moles of uranium cancel out. Now I'm left in moles of UBr6. Okay, but remember that for actual and theoretical yield, when we're looking for the percent, we want it to be in grams, okay? We want both to be in grams. So I'm going to do one more step in which I go from moles of UBr6 to grams of UBr6 by using the molar mass of uranium hexabromide. Okay, so I have uranium, I have 1 of them, and each uranium has a mass of 238.03. Bromine, I have 6. I'm going to multiply that times its mass, which is 79.90. I multiply, I get 479.4. I'm going to add both of these masses, and it gives me 717.43 grams per mole. Okay, so this number I'm going to put here in the top, 717.41 in green grams of UBr6 for every 1 mole of UBr6. Like this, the moles cancel out. Okay, I use molar mass. And now that everything is canceled out except grams of UBr6, I am going to multiply and divide all of these numbers in order to get my theoretical yield. Okay, so I'm going to get my calculator. Do 83 divided by 238.3 times 717.41. And that gives me 250.16 grams of UBr6. So this right here is my theoretical yield. My theoretical yield. Okay, so now I'm going to get this value. I'm going to get this percent yield. I'm going to plug it into my formula to figure out what the question is actually asking me for, which is for my actual yield. Okay, so I'm just going to go ahead and copy this same formula again down here. So percent yield equals actual over theoretical times 100. Okay, and what I'm going to do is I'm going to plug in all my values into this problem. So percent yield, the question gave it to me, was 83%. Okay. Actual yield, I do not know what the actual yield is. That is what the question is asking me for. What is the actual yield? So for actual yield, I'm going to put an X because I don't know what that is. And then my theoretical yield, what goes here in my theo, I just solved for it. It's 250.16 grams. And then I can't forget about that 100. So now all I gotta do is solve for X. Okay, and you could do this in many different ways. The first thing I'm gonna do is I'm gonna get rid of this 100. Since I'm multiplying by 100, I'm going to do the opposite to get rid of it. And the opposite of multiplying is dividing. So I'm going to divide both sides by 100. So that these 100 goes away. Okay? 83 divided by 100 equals 0.83 equals X times 250.16. Okay? So now to solve for X, you see, since I have X divided by this number, I'm going to do the opposite of dividing, which is multiplying. So I'm going to multiply both sides by 250.16. Okay, I'm going to multiply this times this. If I multiply 0.83 times 250.16, that gives me that X is 207.63 grams. Okay, and that would be my actual yield. And that's my final answer, grams of UBr6. And that is my final answer. So remember that here my last step was to isolate X. Since X was being divided by the number, I multiply both sides by that number. So that is my actual yield. That was my theoretical yield.